Hello, everybody, and welcome. This is Buzz Machete at MongoDB, and welcome to today's webinar entitled Migrating from RDBMS to MongoDB. If your travel plans today do not include exploring this topic, then please exit the aircraft immediately and see an agent at the gate. Otherwise, welcome aboard for about the next hour. So, some quick logistics before we get into it. The webinar is being recorded, and the audio and video will be made available to you in the next 24 hours. You can use the chat window for technical assistance or QA. One of my colleagues, Matt Callan from MongoDB, will be monitoring that. So when you see responses coming back from someone named Matt, that's who it is. He's at MongoDB. We'll try to answer those questions as they come up. And some of the common questions that we see repeated over and over we'll leave to the end. I'm going to try and leave about 10, perhaps 15, but probably more like 10 minutes at the end of today's presentation to go over those common questions. Very briefly on who I am. Long story short, for a long time on the other side of the fence, building a lot of the things, and have experienced a lot of these kind of migration and essentially persister swap outs over my career. And at the risk of starting an editor flame war, I still code every day, still using Emacs. So, a brief outline for the things we're going to look at today. We're going to very, very quickly talk about what is MongoDB, just for those people who are out there who may have little or no real contact with it. Then we're going to jump right into understanding what migration means and some of these other topics, and in particular, how some of the caveats about migration versus rewriting come into play. So to start, MongoDB is the leading NoSQL database for a number of reasons, but here are just a couple. First of all, we're fully featured. We can insert, update, and delete, and index, and monitor, and manage the database. Now, that may sound like table stakes for a database, but in fact, in the NoSQL space, for various engineering reasons, some of those capabilities don't exist. In MongoDB, it was important for us to be able to have a database that behaved similar to what you're used to doing over the past N decades in the RDBMS space. And that is largely to be able to have a very symmetric way of inserting, updating, and deleting content, and being able to provide secondary indexes on multiple keys for high performance. What really makes us different, of course, is the document data model. Document does not mean Microsoft Word or PDFs. Document is our term for a rich shape, an example of which you see here on the screen. So in MongoDB, a document or a record is not just integer, double, date, and string. It can be a structure that contains other structures that can contain lists, ultimately, of integers, doubles, dates, and strings. And that's a very, very powerful modeling aspect that we'll see comes to really blossoms later on in the presentation. Lastly, we are open source, but the important thing to understand that's different about us is that we control the open source code. It's not actually community code out there, so the degree to which we interact with our customers to understand where the product should move, we can work in concert with them to progress the product in our own way. And also, we can provide commercial licensing and other sort of legal aspects on top of that. So what are we good for? We call it systems of engagement. And to differentiate that from systems of record are typically your legacy systems based on RDBMS and, frankly, other technologies, where in addition to the persister, the whole mode of interaction tends to be very different. You tend to get into monolithic systems, more batch-oriented systems, long turnaround times, very ingrained and sometimes very comprehensive operational and reporting aspects that have grown up organically over time. MongoDB is best, now by the way, for certain use cases, MongoDB is a perfectly satisfactory system of record if you're starting from scratch, but today we're talking more about migration. MongoDB is very, very good, however, as a system of engagement, which captures some of the bullets that you see here. And in particular, the ability to grow with your user needs, not just in terms of the size, right, sort of the volume of users and the load placed upon your database, but also the information architecture itself, your ability to react quickly to day 2 and day 3 change, and also exploit one of the features we'll see later on about polymorphism and the dynamic schema, where changes to your source systems that are feeding you do not necessarily mean that you have to duplicate every single schema change on the MongoDB side. It's a powerful feature. So getting now into the heart of today's talk, why migrate at all? Migration is difficult. It's not easy. It's, whether you're going to MongoDB or anything else, it is not undertaken lightly. Changing your persistence engine is somewhat akin to a heart transplant. And you only want to be able to do this if there's a pain that you have. And the pain has to be profound enough to invest in not just, for example, a faster piece of equipment. Because typically, and quite honestly, that may be a reasonable alternative. You have to have sort of maxed out, if you will, on some of the underlying issues that are causing you these pains in order to even think about doing the migration. So what are some of these pains? Well, there's no hard and fast rule that says you have to have 2 or more, but we give an example here, or examples, of both software-related and infrastructure and RTO concerns. Typically, if you've got performance where you've just saturated out the number of reads that you can do, or a mixed read-write workload, if you actually want to have an agile SDLC, meaning day 2 and day 3 changes, you should be able to turn around things as fast as your own internal compliance and tests can take you, not because it automatically will always add an extra month of database upgrades before something can be released. On the right-hand side of the page, if you need scale, if you need to deploy globally and have globally replicated data, or potentially take advantage of point-in-time recovery, as in I need to recover to 28.5 minutes ago based on my operational setup. If these pains are inhibiting your ability to move forward, then it's worthwhile understanding what a migration profile would look like. And something that's very important to know when you do this is that it's not the same as migrating from one RDBMS to the next. And to be fair and honest, even migrating from one RDBMS to another is never a piece of cake because the stored procs don't work the same way and some of the queries don't work exactly the same way. But what you need to be able to do is address the whole technology stack. Blind migration, for example, of content from a 150-table schema into Mongo is very likely going to drag in technology and information architecture and, if you will, accommodations and workarounds from the past that you don't want to do. So once you enter the migration waiting room, if you will, it is very valuable to examine the overall stack and the overall system to see where MongoDB plus other changes could really create leverage and value. So what does that mean? What are some of the things that we find when we're looking about this value? Well, this is an extremely complicated formula here, but largely you have to understand what the pain relief and the migration effort components are going to look like. And when you examine it this way, what will quickly become apparent is that it's not a single equation, it's a set of equations. There are different kinds of pains that you can go after which have a certain kind of migration effort relief. In fact, a healthy way to do this would be to come up with 3. One which perhaps gives you the most kind of target value, but with a lot of migration effort, if you will. Solves a lot of pain, but with a lot of migration effort. Looking at it in this way helps you to understand what your ability to execute on these different kinds of pathways are going to look like. And you may decide that you only want to, if you will, take a bite at a small amount of pain for a relatively modest amount of migration effort, but with a higher degree of execution. So we keep talking about the stack, and what are some of the things I can do about making changes in the stack? So we've got the obvious bits here, right? The actual RDBMS, we're going to change that. We're going to look at schemas. I already mentioned that stored procs, if you've got a lot of investment in there, you have to know that they're getting pulled up out of the database because they don't work in whatever your target database is going to be, MongoDB or otherwise. There's also the standard set of ops management and testing environments that you're going to have to set up in order to do this migration. Now, these things, let's just say, are kind of obvious. You kind of know you're getting into this soup. But with MongoDB, it's important to dip down one layer before you move forward. And the reason is that we are, as a truly distributed database, are designed to work well on locally attached storage. So to the degree that you have an environment where you've got, let's say, a SAN. And by the way, we work fine on a SAN. But if you want to, either for performance, for really, really redundant data, right? So you're not even relying on a SAN fabric anymore, or for, frankly, ease of infrastructure management, where you actually want a box that contains its own storage and that box is all quickly swappable. You may want to examine how things are currently connected. That said, that's sometimes often a decision that's made on a corporate level, not on a individual project level, but it bears examination. So let's bounce up the stack again and look at some of the other opportunities that are available. So when you go to MongoDB, for reasons that we're not going to completely cover today, you get a great unified high availability and DR story. And that may solve some of your pains to the degree to which you've got separate environments that deal with replication and disaster and hot and warm, certain regulatory and compliance issues that force you to test prove that your HA environment is working properly. If that is becoming a pain for you, there are opportunities here to use MongoDB. Also, the secondaries, which are our way of getting that high availability, with certain caveats, can be used creatively for things like snapshots of time reporting on things. So you can essentially isolate a database temporarily, do all sorts of extremely heavy workloads on it that would impair the performance on the primaries, on the rest of your system, and then let it reattach. There are a number of different kinds of use cases and patterns that can be brought to bear that use, by the way, the very same fabric that we're using just to provide HA and DR. Now, as we continue to go up the stack, we're going to see that things are now going to start to change. So we do have a set of APIs in 10 languages. They're not JDBC. JDBC is largely characterized as connect, send in a string, and get back a rectangle called the result set. MongoDB has connections. We've got pooling. We can ask questions, and we have a query language. But make no mistake, it is not a string, and it's not a result set. We also don't support, currently in this rev of the product, multi-document transactions. So we're starting to get into that space where your overall design of your system that you're trying to migrate, if it heavily relies on things like start trans, then updating 22 tables and 14 inserts and then doing a commit, simply migrating all that across is, from an information architecture standpoint, possible, but you have to be very mindful about some of the implied, transactionality, right? The overall effect of being able to do that within a single transaction in your existing system. This should be kind of obvious. We're a NoSQL database, so we're NoSQL. We do have a very powerful API, but again, and maybe perhaps more importantly than anything else, the degree to which you're expecting to just ask for a rectangle of scalars, which you're going to unwind based on the construction of a SQL string, if this is not well isolated from your applications, which you see are sitting all the way on top in this stack, then you'll have significant work to do as part of your migration effort. ORMs have made their way into the environment in the past bunch of years, largely because as the language, as the software environment around us has really stepped up and become very dynamic, very introspective, very flexible, the underlying databases haven't. So ORMs exist to change those rectangles of ints, doubles, dates, and strings into real objects that your application wants to use. Oftentimes, that entire subsystem of ORM is unnecessary in MongoDB because MongoDB shapes are already very rich. Lastly, almost lastly, coming up to the POJO layer here, and oftentimes people do not want to make the investment in changing this, but POJOs or C# objects or Perl or Python, it doesn't matter. It's been my experience that a lot of times that code has been constructed in such a way as to ease the integration with the ORMs and to mimic, to some degree, the actual underlying database, because that's how you got it out. And this has some issues. I've run across many an example of POJOs that largely were get and sets of strings, and the contract around these things was, well, is it null? Is it not null? Is it spaces? Is it blanks? If the answer is it's whatever the database gives me, then you're not really talking about a POJO in its own right. You're talking about some sort of a projection over the database. And the degree to which Mongo can give you a lot more expressivity in that space, you may want to examine what it means to change some of these POJOs. So at the end, when you take all this into account, there are really two approaches that you can take. And the analogy I like to use here is the old house. So if you've got an old house, you may know it and love it, but sometimes to fix it, it's better to tear it down and start from scratch rather than systematically and sometimes painfully going room to room, making all sorts of potentially disconnected modifications. And when you start at the bottom, it should be no surprise that if you can change the storage layer and perhaps the RDBMS if you've got good installation, then there's a relatively modest investment and perhaps a relatively modest disruption in terms of your overall transition, your overall migration. But the further up you get, especially, and quite frankly, if you're letting SQL escape into your application space, you're chasing the problem right to the very top, right to the fan out of the technology. And so in that case, it's often wise to take a deep breath and say, are we actually looking at a rewrite kind of approach as opposed to a migration? In a rewrite, because you're going to address the whole stack, you don't keep chasing hurdles that become successfully higher and harder to get across. When you address the whole thing holistically, you can accommodate these things and make, frankly, broader changes that simplify getting over those hurdles as you move forward. So how do you figure out the boundaries here? How do you understand the trade-off? So here is something that you should be doing. This list of design aspects is not from a book. It's a good starting point, however. And when we talk about the difficulty of these things, then you have to take into account that that's subjective, and it depends on your team's skill and experience. But in general, sort of reinforcing some of the themes that you heard me talk about earlier, if you've got very domain, technology-specific things like two-phase XA commit, if you've got all these BI-driven reports, migrating it into Mongo is going to be difficult. But on the other side, if you've actually got a handsome stack that's got a fully factored data access layer, or if your problem domain itself has been characterized as being one where you're trying to store dynamic or polymorphic data, and you've got all kinds of code workarounds just to jam that in to the relational database, that's a plus, right? That's a plus up. And when you add these things up, the higher your score, the more value you're going to get out of your migration dollar. So finally, let's look at the spectrum. This is sort of a summarization. If you've got a system characterized by some of the bullets we see up on top, particularly if it's a very, very, very large system with a well-constructed software stack, it's a good candidate for migration. If it's sort of the opposite of that, and in particular, SQL escaping up into your POJOs and into your applications, and very slow growth, unless there's another pain point that is really driving this forward, you should be looking at the rewrite approach instead of migration. Let's switch gears a little here onto what people are going to be doing differently when they move into MongoDB. There's always been a lot of talk about, with MongoDB, you don't need DBAs. That's not true. It's just that in the MongoDB ecosystem, in the way that people interact with the persistor and the software around it, some of the roles shift. They don't go away, they just shift across people in a slightly different way. So let's look at those things. We've got business users, there's SAs like myself, developers, all these folks. Now the good news is that because we are a mature product that's got security and ops manager and all sorts of monitoring apparatus around it, there are a lot of things that are going to remain pretty similar. Where things are going to change significantly are in the developers and in the DBAs. I'm leaving solutions architects out of this for the moment because solutions architects oftentimes abstract things away. You know, there's a box called the persistence box, if you will, and the way that interacts with message hubs and the DMZ and various B2B frameworks, things like that. It's at a higher level. Some of the capabilities that MongoDB brings to the table may just sort of be implied in their designs. But at the developer, the data architect, and DBA level, the change is going to be profound. And in the next couple of slides, let's try and do a crash course in how that's going to change things. And by the way, the entity diagram on the left is not supposed to be exactly the same as the one on the right. It's a representative example. But your developers and data architects are going to need to embrace rich shape design, and they're going to need to understand the trade-offs. And when you're migrating to MongoDB, some amount of architecture redesign is probably going to be necessary. So if you look at the document on the right, coming back to what I was saying before, it is a rich shape. It's not just name and scalar pairs. They can be lists, complex structures, etc. We call this embedding. Now, where embedding is going to be really important for you in your migration is understanding the one-to-n belongs to relationships on your RDBMS side. Also, those kinds of designs in your legacy persister where there's a great deal of what we call polymorphism, like a product catalog or an events collection, where typically there's maybe a main table called product, but 22 other little tables off to the side of it that carry specifics for different products. You wouldn't model it that way in MongoDB at all. And in fact, this is why in a lot of MongoDB information architectures, you end up with a dozen or so collections instead of the hundreds, because instead of having to have a table for every one of those one-to-n relationships or extra tables to hold on to data not appearing, the 80-20 rule, not appearing in the 80% of the common data, you don't need to be able to model that. Very important for your data architects to ingest. And as a quick example here, we just show what might commonly have been done in the RDBMS world versus what you would want to target in MongoDB. So in theory, the RDBMS team did a good job already because the one-to-n relationships have been set up into their own tables. Now, we all know that this is the good example. There are many, many examples where teams, due to time, organic growth, etc., have not done things like this. And for small things like tags and categories, designers will take a shortcut and flatten out the data, right? And so instead of having tags as an array, it'll be tag 1, tag 2, tag 3, and that's all you get. Sometimes in order to avoid the n+1 problem, there'll be a column, a string column called tags, that contains things like tag semicolon, semicolon, tag semicolon, and a semicolon delimited array inside of one field. These are accommodations that are very, very often made to avoid creating yet another table. You don't have to do that in MongoDB. So as we see on the right-hand side, we've kept article and user collection separate because that makes a lot of sense to do. And we'll use foreign keys to reference them. But specifically with respect to comments and tags and categories, those are all going to be embedded inside the article itself. There's another very, very important aspect for data designers to understand, and that is structures beyond scalars. And this is a very underlooked and very powerful component of MongoDB. This is usually what you see on the left-hand side. This is what you see with RDBMSs. You see a bunch of column names. Now, on the right-hand side, and we're doing a mixture of pseudocode and sort of representative example work here, we're using a combination of software to make us a map, and then inserting that map, that rich structure, directly into MongoDB. So let's just assume for a moment, and by the way, I deliberately left out for my example here middle name. Middle name was null, so it is only first and last in this particular structure. What becomes important is that you can gracefully pick up new fields. So as my model changes, and now I've got to I have to include nickname in there. On the left-hand side, what do? Well, obviously I have to change my schema to add nickname, but all of my investment in my code that did inserts and selects has to now add nickname in. On the MongoDB side, I change my map to include nickname, and there's no change in the investment in code to insert and find these things. Now, where this becomes really interesting is when it's not just of the buyer's name. Suppose I have the seller's name and the lawyer's name or anybody else's name. On the left-hand side, I've got a lot of very tedious work to do to essentially copy all those individual columns. And by the way, I'm not even touching upon the difficulty if this starts getting split across multiple tables. In the MongoDB environment on the right-hand side, I have to make a modest investment in creating the new seller name, but a lot of the machinery to insert it and find it remains the same. This is much, much easier to copy and paste, if you will. And then ultimately at the end, you end up with this on day 3. Now I need to add title to all the names. And I'm faced with, well, where are all the names? By the way, in this example, I'm only showing you things that have first name and last name. There could be all kinds of other columns involved in here. So to which ones do I add title? Now we can already see that the team has run into a little bit of trouble here. Somewhere along the way, clerk never got a middle name. Some number of queries that were looking for clerk didn't ask for its middle name, so it never got added. And something else called a queue showed up. But the queue in this example is not a name, like first name, middle name, last name. It's a token on the queues. The point of this kind of an example is that it becomes increasingly difficult to even use the column name patterns as a reference point, right? As a means of finding what needs to be changed. So with MongoDB, you could probably see where this was going. In my mappers, I create a title, and then I do an insert and a find with no change. Now, this is an important, again, thing to understand when you're looking at migration, because if you're not exploring this kind of an information architecture shift, you may be leaving money on the table. You may not be fully capitalizing on the power of MongoDB as you move across. It really comes down to choice. So I won't read through all the bullets, but largely, the less schema that you have to change, the easier it is to work, But you, again, may not be setting yourself up best for day 2 agility. You might pick up infrastructure performance and scalability, to be honest, if you've got a relatively small schema, very tight, and have just run out of steam in terms of scalability, it may be perfectly appropriate to migrate that directly into MongoDB and take advantage of sharding and other aspects of the platform to improve your performance without diving deep into the changes in the information architecture. Of course, investing in these things, as a more of an upstack kind of guy, I'm always looking to see how the software and the database can cooperate more effectively. I would always say that it's best to start at the high bar and assume a lot of information architecture change, and then only as your ability to execute upon that really starts to come into jeopardy to start to back down. Put another way, don't start with your 150 table design and work forward. Think of a target architecture and then work backwards. And again, do not forget the formula. We talked before about there's a set of these things. You may be able to, without major schema change, take advantage of what MongoDB has to offer. Finally, I want to talk a little bit about DBAs before we move on to our next topic. So this is pretty much how I see the DBA roles and responsibilities laying out in RDBMS versus MongoDB operational support over the past couple of years. And the fact is this. In any technology, you're going to have a small number of experts. Depending on the size of your organization, 5. Remember, you don't want to have 25 experts in here because they're all going to be yakking at each other about what's the best thing to do, and you want to avoid academic debate. But you're going to have a small number of experts. When you go up from there, you want to have a bunch of real administrators, people who are doing the leverageable tasks and activities. This is security work, this is backup and maintenance, this is understanding how the database is going to be working with your VM environment and doing configs around that, those sorts of things. The big difference is at the top of the tier here. Historically, a lot of DBAs end up in a non-leverageable role. It's the DBA who unlocks, the deadlocks that occur on that fixed income database over there because he knows what patterns to look for in the logs and has the privilege to break those locks in production. There's going to be the guy who works with the development team to create yet another alter table Perl script that's got to do this mass migration of the data, and he can execute it because he has permission to do so. Now, some of those jobs continue on. And for segregation of duty issues, you may still choose to have some of them carry on. However, for a large number of them, the scale you've already achieved at the development, right? Developers are the leaves. There's no leverage in a developer. Developers building codes, unless it's like low-level live code. Developers are your investment in the application and the degree to which they can take on some of the traditional roles of moving data from one column to the next or from one collection to the next, pre-production. This, frankly, offloads that work so your people can focus on that middle tier and actually get better at integrating monitoring and operations. Let's move on to bulk migration. So, assuming that you've written a piece of code, you've got your data design going, you've listened to everything that I've said over the past half hour, now it's time to get some data in there. And pretty much you're always going to want to take some amount of old data and bulk load it in. And you'll want to do this maybe over and over again to experiment with certain performance, certain design issues, etc. Experiment with different indexing. So what's important to know is that when you start the effort, you don't have to have a completely operationalized, turn the crank way of doing this. You'll want to approach it in an agile way. The good news is that there are a number of tools and techniques to help you get from where you are to where you want to be in your end-state MongoDB installation. Let's look at the easy one to start. Mongo import. So if you can, here's an example of a JSON file, character return delimited JSON. If you can start with this kind of data, no matter what the source, it's a fine way to get the data in. It's pretty easy to construct character return delimited JSON, easier than XML for a number of reasons, including the fact that arrays are natively supported. Also, without having an XSD, there are conventions in MongoDB to allow you to represent dates. And one safety tip I can put out there, I have seen so many data integration environments go south because of the inability of systems to properly communicate the type of a date from one side to the next. Things that come across as strings or integers, over time, something gets lost along the way, and you no longer interpret it as a date. Or the data coming across as bad, and a string, which looked like YYYYMMDD on one day, the D got dropped because somebody changed the code, but because it still is a string, it gets pulled in and then interpreted, well, improperly. We hope it's interpreted as an error on the receiver side. So you'll want to take advantage of the MongoDB type metadata conventions for properly moving dates and other types across as strings in your flat files. Now, of course, there's also traditional vendor ETL. Now, here, long story short, you'd use it pretty much the same way that you've always designed and configured and operated these typically graphically oriented products. Pantaho and Informatica have a partnership with MongoDB, and they're pretty powerful in offering mapping, workflow, et cetera, et cetera. They're pretty good at handling different sources of data, so you can point at multiple DBs as part of your exercise of moving it into a common set of collections in MongoDB. There are going to be, obviously, limitations in this space. Historically, most of them are designed to move from one set of rectangles to another set of rectangles. And their ability to, I'll say, deeply embed lists is oftentimes in the GUI not properly expressed. The irony is some of them at the command line level do a better job of it. And there are certain tricks that can be employed. But we're still growing. The ecosystem is still growing in this space. If you're going to approach things with ETL, again, I want to reinforce what I said a couple of minutes ago. Start with your best model in MongoDB, your most appropriate, your richest information architecture. And then find the best ETL tool that can get you there. Don't let the tail wag the dog. Don't let the ETL tool that you have drive what your ultimate information architecture in MongoDB is going to be. It's a short-sighted move that leaves you with your ongoing persister with not the very best data representation that you could have. Focus on the prize, then get the right tooling to load it up. There's also the community. The community in MongoDB is enormous. With 10 million downloads and actually almost 1,000 partners now, a lot of university work, etc. If you go out to GitHub or just Google for this, there are tools everywhere. Some of them well supported, some of them incredibly well supported. We offer as an example here something called Firehose. If you didn't want to use an ETL tool or Mongo import and you just want to kind of load things up on your own, you can do that. You can split apart these things and substitute in your own sources, some of your own processing logic, etc. If you're going to build a custom loader, instead of starting with just from blank with main.java, you may want to take a look at this. There are a number of different kinds of loaders out there. MongoMT import feels a lot like the factory version. This one offers you the ability to plug in your own custom Java classes. So if you've got very special logic, which obviously the factory version is not going to know about, in terms of conversions, integrating with ref data, all sorts of things that are bespoke to your environment, you can use this tool as well. Lastly, if you've got a very, very sophisticated environment, and you've got some amount of Perl expertise, I recommend looking at R2M. It is a nice bridge between the environments that are very rectangular and very dynamic, leveraging the fact that the DBI framework will allow you to connect to pretty much anything. Oracle, Sybase, MySQL, Excel, web services, it almost doesn't matter. There are dozens and dozens of source-side adapters in the DBI framework, and the whole point is R2M allows you to specify how you want to push that data into MongoDB. In particular, and then we'll move off this topic, it works very well for embedding. So again, those belongs to one-to-N kind of relationships you'll really want to capture. So instead of moving contact and phones into their two separate collections in MongoDB, you would want to end up with a collection where a name has an array of phone numbers associated with it. And R2M provides a handy way of making that happen. So let's talk about system cutover. System cutover, obviously there are a number of approaches that can be taken. It's very, very important not to think about this 10 minutes before you go into production. From pretty much the day you start your migration effort, you want to look into the future. You want to look 3 months down the road and say, assuming it's all functioning correctly, what are the options that I have for actually making my new thing go live? And the very first thing that we want to assert is test. Very often, people choose MongoDB as a migration option to capture infrastructure scale performance, as I mentioned before. If you're going to do that, then what you really should do is build scripts that basically break the product. Whatever your performance and volume requirements are, 4x them and see where the natural breaking point is. And it's important that you identify the bottlenecks ahead of your stated performance requirements. Remember, you don't have a lot of experience unless you've been migrating a lot of MongoDB. You probably haven't. There are years worth of built-in assumptions about how RDBMS systems perform. As you do this migration into MongoDB, especially if performance is an issue, test it, test it, test it. Now, here's approach number one for doing the migration, the hours of downtime. Not terribly sophisticated, pretty obvious. The pros here should be obvious, and that is you're essentially creating a parallel stack of code. It may look in here that I'm rewriting everything. It's not necessarily true. The migration here is basically copying the whole code base over, maybe making modest changes, but it is two separate code bases. On one Sunday night, you shut the whole thing down. That arrow on the bottom there is the mother of all scripts, and you sort of are very nervous as it runs, and it transfers all the data. Then you come up live on the new stack. The cons, of course, are that arrow. There could be a lot going on in that arrow. The good news here is that if the arrow doesn't work, you still have an existing system that's running pretty well. So if you're very, very conservative in your approach, this actually isn't so bad, because if you don't rely on the arrow, you can always say it didn't work, and you don't switch into the new stack as we see on the right. Now, a more intellectually interesting approach is the minutes downtime. Here, what we're going to do is actually build a real integrated stack. And especially for someone like myself, it forces the fact that you're going to have a data access layer in there. And I'm not saying that that's necessarily easy, but if you do it, one of the benefits of doing this is that you do get a data access layer out of it, which is good software engineering to begin with. And as you can imagine here, what happens is at the point where you're going to do the conversion, what's been continuously being migrated from the RDBMS to MongoDB at Sunday night, when we shut down the application, only that small bit of data that has not yet been shifted moves over, and then at the software level, the dial is switched. This can be done through environment, so you don't have to do a new release, right? The application, when it comes back up, is now looking at a new environment variable that now shunts things through the path into MongoDB. The cons, obviously, are that you may not be able to engineer a DAL, or you may not be able to tolerate whatever that last flush of activity is. Finally, there's the zero downtime approach. This is pretty sophisticated, and very quickly what happens is this. The applications, as they're doing their normal read-write activity, they always hit the Mongo side first. Now, when you start from zero, there's nothing there. So the shunt in the DAL turns around and goes through the legacy stack to perform whatever operations it needs to do, and puts the data onto the Mongo side, then essentially turns around and makes the call again, which, surprise, it succeeds. This is a way of letting the application do the work for you. You'll see that we've got two examples of shepherds here. A shepherd is a sort of tunable load generator that just sort of steps through and nudges all the data in order to activate this kind of shunting activity. And what's going to happen is at some point, there will be no more activity. At no point will the calls into the Mongo side fail because of something not found. And then, again, with a software switch, you no longer go through the legacy side, and at a certain point you can actually disconnect the rest of the codes. The cons are that this is a pretty sophisticated environment. You do have to be able to suffer through the performance hit of moving from one thing to the other. But if you're not in a high performance, tens of thousands of second transactions mode, or even higher than that, this may be a perfectly acceptable way to do your migration. And what's really nice about this is that along the way you get to see how your performance and your overall monitoring and management of the system can grow and evolve. There's very little in the way of a step function here. In fact, shutting off the shepherds and the rest of the shunts is basically a non-activity. Right? It's just one day there's some sort of a maintenance upgrade. Now, that's a lot to absorb in 45 minutes, but we are here to help. MongoDB has consulting, we have professional services, we have development support. There are a number of different packages and approaches to working with us to explore these options and this whole problem space in general. With each passing month, as we gain new customers and new projects, our experience in this space is growing. And there are a number of stories. Yes, believe it or not, people have been successful in doing this, including one of my favorite examples is Craigslist, which had in their archive database a problem where an alter table statement that they had to create didn't take hours, not days. It took weeks to complete. And at that point, they said, you know what, we can't have the DDL getting in the way of these things anymore. And they switched to MongoDB as a migration of a multi-billion row database to capture the fact that as new data goes in, they don't have to do the alter table problem. So that was a very good story that capitalized on both scale and our dynamic schema ability. And with that, it's about 10 minutes to the top of the hour, so I kind of squeezed it in to where we wanted. We've got about 10 minutes left here, so we're going to now open up to questions, and let's see what we got here. And thanks to Matt and the team for handling some of these. So I'm going to take an easy one at the top. In RDBMS, we have SQL. Do you have a logical language such as SQL? Well, we have, being a little tongue-in-cheek, we have MQL, which is Mongo's query language. Mongo query language can be characterized as a prefix notation language, operators, and operands. And so all of your standard ands, ors, greater than, less than, date math, all those sort of things are available. In particular, group by, our aggregation framework, very, very powerful. As a software developer, I can tell you it is much easier to programmatically construct our Mongo query language and pass it into the APIs than it is to programmatically construct a SQL string and pass it in. But the capabilities of both are very close, and it's one of the important differentiating aspects of MongoDB. How will RDBMS data to Another question is, how and where will you map RDBMS data types into Mongo data types? So RDBMS there's only one data type that I know of that gets a little tricky moving over, and that's big decimal data. Big decimal you can express as float in MongoDB, but that's typically not what you want to do, especially if you're in a financial services application. Other than that, all the plethora of varchars and texts and all those guys, they come across as strings. We support both 32 and 64-bit integers and dates. especially dates. So there's actually and binary data. So that really is the nucleus of all the kind of types that you would want to move across. There's another question. How do you say load balancing? Here's another good one to get on the books. Is Morphia a good framework to work with MongoDB? The answer is yes. It was written by one of our engineers. It is a annotation-based way to take your POJOs and connect them up to MongoDB and get all that read, write, and find and insert and update behavior for free. Now, I will say this. In terms of stack development, I'm always a little bit leery about annotating POJOs with connector frameworks because it tends to start to drive your POJO more toward being database oriented rather than just being a POJO in its own right. The good news is this. Unlike Hibernate and some other tools, if you've got a POJO that has a list of things, Morphia will just turn that into a list of things and put it into MongoDB. So the performance of your environment roughly remains constant as you expand your POJOs. As the amount of data going into your POJO expands, you get relatively linear performance going into MongoDB. Everyone has heard the stories of what happens when you try to do this with relational-based ORMs, where as your objects become more complicated, the number of tables and the kinds of statements and the joins underneath that are required to prevent the data becomes much, much heavier weight. DTS. So a question, how do we migrate our stored procedures in MongoDB? So your stored procedures would move up stack into your data access layer. MongoDB does not have stored procedures. Stored procedures are, this is not the forum to sort of debate the pros and cons of them, but I do assert that in terms of parity of migrating from any RDBMS to anything else, MongoDB or otherwise, you would face these kinds of issues. If you're a big Sybase shop now and you wanted to move to Oracle, you would have exactly the same issue of rewriting, frankly, all of your stored procs, and in fact dealing with the fact that some of your joins, which are performant, and the hints, especially, that you've applied in one RDBMS, do not translate to another. Common question here, but a good one. Is there a preferred UI client to support DB management? There are several in the field right now. They are RoboMongo, MongoView, and uMongo. There are two commercial products, JSonar and Pentaho's own visualizer, which are good. As announced at MongoDB World, with 3.2 and another couple of months, frankly, MongoDB will have a factory-supported GUI tool that will allow you to connect up to a DB, look at the collections, issue queries, look at stats, things like that. Here's a good one. Is it possible to build a highly concurrent queue-based ticket system in MongoDB? The answer is yes. We have a very exciting design around that. We can talk about that offline. But it's a very good example of how MongoDB and its polymorphism in particular can really be brought to the forefront to make this, that solution work well. Another question, what would be the best way to validate the MongoDB structures made for efficiency? So that's a great question. I'll back into it by saying in 3.2 we're going to be offering some amount of document validation. The current approach is going to be to take and I spoke about this at MongoDB World, so you'll be able to look at it in the presentations that are going to show up on our website soon. But the same query language that you use to filter data coming out of the database, you can turn it around and use to filter data going into the database. So you'll be able to use the rich expressivity of MQL in order to validate what goes in or out of it. In general, I will say this. Validation of data is not just a database problem. It is a problem of the solution. Because, and my favorite example, settlement date and trade date, they're both dates, both non-null. utterly unimportant to the success of your system. Not important at all. What is important is that trade date comes before settle date. What is important is that trade date comes before settle date unless the instrument is an equity, like a listed option, and then I got to look at expiry date. All of a sudden, there's a lot of logic, and sometimes business logic, sometimes context-dependent business logic that has to be applied before you know that the record can go in. Now, that's not expressible in the database. So what you end up with over time is a mixed bag. The database is enforcing some things, and your code logic is enforcing some things. The MongoDB paradigm is, well, as long as your code has to manage some of that, why not have it manage all of it, and let the data access layer be sort of the final arbiter of what's going in and out. And among other things, this makes testability easier, and it places a lot more ease of management in your SDLC by only having to watch in one place where these decisions are being made. How do we deal with data in MARTA? How do views? So there are a couple of questions about views and referential integrity and joins. So largely these things, these actions that you take in the traditional RDBMS world are now done in your code. So instead of doing a join, for example, on contacts and phones, if you can remember back a few slides, if you don't embed it, let's just take accounts and transactions because that's better. If you wanted to find all the transactions done on a certain date range by a certain set of accounts, what you would do is probably ask for that account range, the transaction range first. Given them that set, you would say, within that set I've just found, does it contain these accounts? Now, that's a two-pass operation. Yes, it is. However, the amount of code that you're going to write in order to actually get back into your application space, which is an account with a list of transactions, which is what you want, that's what you want, right? One account mapped to a list of transactions, is no more than the amount of code you're going to write in SQL to unwind that result set that's got in that join a repeating set of accounts. Now, if you've kind of followed where I'm at now, and I know it's a little hard without showing the code, imagine an 8-way join where there's order bys and you've got accounts and dates and all this. Now, the SQL query will function. Yeah, I got that. Look at what the result set is going to come out with. There's going to be 20 columns of which the first 10 repeat over and over and over again. Some amount of code has to sit through that and watch very carefully for when columns change, for when certain states exist, in order to ultimately turn it back into what the application wants, which is not a big rectangle of repeating data. And so how does it deal with it? The answer is actually you're thinking about it before you make the queries instead of doing it after the queries. And we've got time actually for one more. 110, let's see, we're doing the ID. That's kind of broad. Tool. So I mentioned the subqueries and the views. Are there plans? Are there plans? This actually came up twice, so I'll mention it just now. Are there plans to implement transactions across documents? The answer is yes, there are plans. It's on the roadmap. It's not coming out in 3.2. It's possible to do. The real challenge here is making sure that transactionality functions properly in a sharded environment, which is another hallmark of MongoDB, its horizontal scalability. And so stay tuned to this channel for that, but it is definitely something that we are working on. And with that, I think that kind of brings us to a minute over the top of the hour. So I thank you for attending today. I hope that what you saw and heard gave you a little bit of insight and some clues and maybe some identification of the sharp edges that you can hit if you go into your own migration effort. Remember, you can always reach out to us at MongoDB for guidance. And with that, code well and be well.